So masonry construction, typically when we think of masonry, we think about really hard objects. So you got, you know, sort of your steel fixings like dyno bolts and ramset anchors and chemset and whatever, you know, referred to as masonry fixings, because they fix well into hard objects like concrete as well. So you use your masonry fixings on concrete. But technically, masonry is anything that's joined together by individual units. So you've got individual units as a brick, for example. That brick is bonded together with mortar. So technically, that's a form of masonry. But you've got other forms of masonry, or technically, that could be mud. So mud bricks come under masonry. Glass bricks come under masonry. With your masonry, you've always got your perpend joints. So these are your vertical joints, and then your bed joints. I'll grab that one over here there with me. One really important thing to remember, and something I've used this a lot, is to remember the standard or the size of a standard brick. With 230 76 by 110, so it's 110 wide from here, 76 millimeters tall, and 230 millimeters long. Which, when you put a 10 millimeter mortar gap on that, makes it 86 millimeters high, 240 long, and well, it's only still 110 wide. But sometimes when you've got piers, you got your 110 with your mortar joint, and then another 110 as well, bring it up to 230, which is coincidentally the length of a brick. So so that's why we have those standard units of a brick, and that's a really important thing to remember. Well, it was important for me to remember because I did a lot of detailing up of places from photographs. So you know, when the New South Wales office was busy, they'd be taking photographs of buildings over there that need detailing up for repair and reinstatement, and then sending them over to me, but sometimes without measurements, so I've got to count the bricks and so on to get ceiling heights and to get sizes of windows and all that sort of thing. It's something I found myself doing a fair bit, and so it may be that you have to learn your brickwork dimensioning very well. Also, beyond your standard clay bricks, we've got concrete blocks as well. So Besser blocks. So these are well, known as Besser blocks in South Australia. So these are concrete blocks with a hollow accommodation that enables steel to go in there, and for Caulfield concrete blocks, which is where you get concrete and pour, and you fill up these cores to provide additional strength. Also natural stone. So in South Australia, we've got a lot of natural stone to work with. Some fairly, I guess, fairly one that's become a little bit more in vogue again is Kanman2 bluestone. So has anybody seen, or can you think of any natural stone that we use in South Australia at all?
I'm not sure of the name of it, but it's in the bathroom, sandstone.
Yeah, we do have a lot of sandstone in South Australia. So Mitcham was a place a lot of sandstone was mined, but you've also got Carey Gully and Basket Range sandstone, and both Carey Gully quarries and Basket Range quarries still operate. Yeah, there's another one out the back there as well, out behind Basket Range, on just near Forest Range. But I can't remember what that one. That one might still be called Basket Range Quarry actually. But anyhow, there's a few. There's that one Basket Range Quarry I know of, and then the Carey Gully Quarry as well near that. So they mine sandstone there, and that's sandstone for sawn sandstone, like you might see in bathrooms and so on. Or a lot of on North Terrace. If you go down North Terrace and look at the State Parliament building, and then the library and the university and the museum, etc., all made out of sandstone. A lot of that sandstone came from Mitcham.
Sorry, Michael.
Yeah, that's fine.
Sorry,
Yep.
I'm really wondering, is this nature stone?
That is natural stone.
Yeah.
So that looks more like the Wollonga slate. So from Wollonga, which is that's in just south of here, only about half an hour's drive down south here, heading toward Victor Harbour.
Yeah.
Yeah.
So
Yeah.
this one's
So that certainly looks like that looks like natural stone. Yeah. And you get that colour variation because that's in the fissures between the stonework. You get staining from oxides and whatnot in those bits. So what they do to get slate is they'll pull out large stones and then tap them and they split.
Yeah.
And they split on those lines, and that's how they produce those tiles like that. And that's why you get that colour, so much colour variation in there as well. C4M&Mweek5 bluestone also has a fair bit of colour variation, but not quite to that extent. Yeah, so it could be, but others. So yeah, so you've got Wollonga slate that do a lot of that sort of slate flooring, but then you've also got Mintero slate. Has anybody ever heard of township of Mintero out near Clare? So also, yeah, that's much higher quality slate, more for billiard tables and things like that. So you would have heard of slate top billiard tables. Yeah. So plenty of natural stone to choose from in South Australia. Even we've got granite being mined around the place as well. So crushed granite, and there's also Mount Gambier sandstone as well. So down in Mount Gambier they've got Mount Gambier limestone, not sandstone, limestone, which is a much softer stone. It's still a sedimentary stone, but it's much softer than sandstone. And that can be sawn into blocks. So they will cut a big flat section and then go along with a saw and cut it into these large blocks. I think it's a really good building product myself. There are some old housing trust buildings built in around this area that use Mount Gambier limestone, but apart from that, you typically don't see it up here. You do see buildings built with it down around Border Town through to Mount Gambier, down around there. So there's that natural stone as well. Also we've got autoclave aerated concrete, Hebel. So that's a Hebel block there. So so probably a bit lighter than what you'd expect. And that's some WA limestone. Probably slightly heavier you'd expect after having had a look at the.
They look the same.
Yeah, I know they look the same, right? And you expect, oh yeah, that one's going to be, yeah, exactly. So yeah, and that's not too dissimilar from that Mount Gambier limestone as well. So that's like that Mount Gambier stuff. Whereas this is a manufactured product, so it uses sand, cement, and water, and then a foaming agent, which is like an aluminium oxide. That when it comes in contact with the cement, it forms lots of air bubbles. Those air bubbles get trapped in that cementitious slurry, and then it's baked. So it becomes hard and a little bit brittle. Or actually, got here calcium silicate bricks. I don't actually know what calcium silicate bricks are. In terms of that, I don't know about us using any of those in South Australia. I've never come across calcium silicate bricks before. Certainly glass fibre reinforced plaster, and also glass fibre reinforced concrete as well. And plastic bricks, well, I haven't come across us using any plastic bricks either in South Australia before, but technically, I guess it comes under a form of masonry. What I have seen a bit of though, which is also a good product in its, for certain applications, is essentially it's like sections of timber made from recycled plastic bags, and includes wood dust as well, sawdust in it. Has anybody seen that stuff before? So yeah, so it doesn't have the compressive strength of timber, and so actually you may have seen it for garden stakes. So at Bunnings sometimes you can buy these black plastic garden stakes. That's that recycled plastic bags. It's that same, which is also similar to a product called modwood, which is a plastic wood composite as well. Modwood looks like timber slats for decks, etc. But it's actually what's part plastic, part timber. Yeah, I can't remember the name of any of the products that are the recycled plastic bags, but you'll see them used a lot for bollards and wheel stops. A lot of your wheel stops in car parks are made from concrete, but then you'll also see them, particularly ones near the beach, are made from these recycled plastic bags, plastic bag material, and also for jetties and things like that. You see it used on jetties. It's particularly good in places where you've got a lot of moisture to be worried about. I've specified it twice. Once it was as a packing material in a retaining wall. So a retaining wall that had earth in behind it had to use very large universal beams, much larger than the width of the sleepers. So there needed to be some sort of packing material in behind the concrete sleepers. And so that recycled plastic bag timber works really well in that scenario. And also under a deck which was only about this high above an old concrete surface. So another place where you get water aggregating under a deck. You don't want that timber to have wet feet under there and soak it up. So in that scenario as well. But clay bricks are very important. I guess very ubiquitous material in construction. Certainly in South Australia, and then as you you go out of South Australia heading to Victoria or so, you'll see far more timber buildings. But in South Australia, a lot of brick veneer. So it's important that the bricks do have very reliable dimensions and also are tested for efflorescence as well. A lot of these actually, that's not written on that. That's not efflorescence as such, but efflorescence you did get it a lot on a lot of these cream bricks though. Efflorescence is when you've got dissolved salts and minerals that end up coming out of the brickwork over time. So from some moisture coming out of going into the face of the brickwork and coming out again and drying on the front face, carries these tiny little bits of salt and minerals, and at times they're a yellowish colour like this. So you want to use clays that don't have a high salt content in them to minimise the efflorescence. Also you've got the concrete bricks as well. Don't have any concrete bricks, but in regards to I'll say it, the word well, in regards to shrinkage of bricks, so clay bricks don't do a lot of shrinkage, or they don't shrink a lot. And when you combine a clay brick with a cement mortar, as that cement mortar goes off, it shrinks slightly, but the brick expands slightly. So you don't get a lot of expansion or contraction when you're laying a fresh brick wall. But with cement bricks, if they haven't cured properly, what they do is they continue to shrink a little bit over time until they're fully cured. I had a look at I was doing a final inspection before sign off for a place in Murray Bridge, and when I got there, the brick control joints, which are joints in your brickwork to allow movement and also allow some shrinkage, they're meant to be 10 millimeters. These ones are about 20 millimeters, and the foam packing in the control joints was like this because what had happened is the bricklayers had laid those concrete bricks and those concrete bricks had continued to shrink, just ever so slightly. So we're only talking, you know, a shrinkage of about 10 millimeters over 6 meters length, but that's enough to cause quite a visual problem in the building. Plenty of sort of modern approaches to brickwork with glazed bricks as well, and certainly making a bit of an appearance in respected architectural circles. Just some aspects around the Australian standard that governs the size of bricks. So the length of the clay brick is to be not less than 1.5 times the width, nor more than 390 millimeters long. The height is to be no more than 70% of the length gross volume of the unit, not exceeding 0.004 cubic meters. That's not going to be an issue. Typically, you go to buy bricks. Bricks are a size. However, one thing I like to show here. So we've got two different bricks here. So that's, what does that one say? Oh, reduction 5. Anyhow, so that is your standard size brick, whereas this one is what's called a metric brick, and these ones didn't really stick around for long. You'll notice that this one is thinner than that one, but longer. So this one's only 90 millimeters wide. So or metric or modular bricks. So you've got your common brick. That first one there is 230, 110, 76. Your modular brick is 290, 90, and 90. So it's 90 millimeters high, 90 millimeters wide, but yeah, 290 long. So the reason for that is that when you put a 10 millimeter mortar gap on that, it's 300 millimeters long, which is a very common increment in construction. So your studs are at 600 centres, which is, you know, 2 lots of 300. Your plasterboard sheets at 1200 wide by 2400 high. You know, so many increments of 300 millimeters within building. But strange enough, well, not that strange. Within building design and what people want out of buildings, people can be fairly conservative, and so although that's a relatively practical dimension for a brick, it just didn't really stay. Like, consumers wanted this size brick to be expressed in their walls. Also, yeah, beyond that, there are some of these jumbo bricks as well, which are 390 long and 110 high and 110 wide and 90 high. Some terminology in regards to brickwork. So these corners here are called an arris. So that edge is an arris, and I don't think I've got a tumbled arris brick in here, but can any of you think of what that would mean when I say a tumbled arris brick? Have you ever seen any brickwork like that? Yeah, they're rounded on the edge. It was a thing in the late 80s thing to do there, where when the bricks are still soft, so the bricks are formed with the clay, they tumble them a bit, and and all the corners get banged up and all soft. The front face of a brick shown in the brick wall is called a stretcher, and then what's our and the short side, when that appears in a brick wall, is called a header. This particular way of laying bricks is called stretcher bond, and that's predominantly what you'll see with brick veneer dwellings. The reason for that is that all your bricks, you only have a single layer or single leaf of brickwork, so all your bricks are going to be heading in the one direction. With your bottom layer of brickwork down here, you have a weep hole, so that's where you don't use any mortar for that perp end joint. So these are your perp end joints, and that's the perp end, and these are your bed joints. So the lines along here, they're all bed joints, and the vertical lines are your perp ends. For suspended floors, you need to have vent bricks as well to ventilate the subfloor space. So if you see a brick wall with vent bricks around the place, then you know that it's a suspended floor. So other types of brick could be things, a bit heavy, mud brick. And yeah, so not particularly common in Australia, but actually, what's that? Quite soft, yes, yeah. But actually, really common around the world. For anybody who's travelled in South America or so, or in the Middle East, a lot of mud brick is used in the Middle East as well. I guess not so much for new construction. You're not going to go central Dubai and see mud brick buildings going up there. But in a lot of the traditional architecture, you head out into the desert cities, etc. A lot of mud brick used there. Also, rammed earth construction. So both of you know what rammed earth construction is?
Caught like the last half of the talk.
What's that?
Caught like the last half of the talk on Monday, but I didn't get the first bit. But I think I got the idea of it.
Yeah. So rammed earth, what it is it's where you get soil, and it's a certain mix of soil, so a certain amount of clay and sand and finer aggregates. And then you also mix in a little bit of cement. So for stabilised rammed earth, you mix in approximately 17% cement powder, and then you use a hydraulic ram and you squash all that soil down, and you pack it all down to make solid walls like this. One of the issues, and I missed the first part of the rammed earth, so you missed the first part as well? Yeah. Right, so we're in the same sort of scenario, or same sort of situation. One of the big drawbacks with rammed earth is that it doesn't provide very good insulation. If you use it as an external wall, you lose a lot of heat through your walls. I've been in a full rammed earth building. I rocked up there early in the morning, about 7 o'clock in the morning, went inside, and it was cold. It didn't really retain the heat all that well. It's fantastic for thermal mass. It certainly takes up heat and gives out heat very well. So it's really good for walls inside your building. But as an external wall, it doesn't have a very good R value, so resistance to the transfer of heat. So what that fellow was talking about on Monday, section I missed, I got told by somebody else, is he was talking something about having now they've developed a way of doing rammed earth with a layer of insulation part-way through the wall. But exactly how that's done, I don't know. I'd be interested to see how that could be done. Apart from that, if you're using it as an external wall to meet the R value requirements of the National Construction Code for Climate Zone 5, where you have to have R2.5 in your walls, you've got to do an external stud wall and then insulation, and then you clad it with something else on the outside. Well, no, you can use it, but you just have to insulate it on the outside. Yeah. Or you can insulate on the inside as well. You can do rammed earth on the outside, then you can do a stud wall on the inside, and then insulation and plasterboard. But that's not really taking advantage of the thermal mass of rammed earth, which is, I think, one of the major benefits of it. Also, it also looks quite nice. There's have either of you seen any rammed earth buildings before around South Australia? So, probably the most notable is on the corner of, what is it? I'm not sure if it's North Terrace there, or it's on the corner of Hackney Road and North. If you go to the Botanic Gardens, and you've got, so where, the National Wine Centre. That's the building I was trying to Yeah. So the National Wine Centre is a massive big round earth wall. And I'll bring up the picture. So the concept behind the National Wine Centre, or what the architect's thinking in regards to that, was that they would get the soil from the 7 renowned wine regions in Australia, truck it all in, and produce a massive big round earth wall with that soil. So. So where's something that shows that wall really well? That one shows the wall fairly well. So that red wall there, that's a round earth wall made from soil that's imported in from like Hunter Valley and McLaren Vale and Nuriootpa and Barossa Valley, etc. So all that soil was all brought in. Yeah, and so it's a massive, big, slightly curving round earth wall. But then on the outside of it is just this curved timber slat work to produce the the aesthetic of an old wine barrel type thing. I quite like the building. I don't know who the architect was actually. Does any of you know who the architect was on that? But there's certainly down south of LA. There's a lot of round earth building. Yankalilla School for their sports hall got a round earth building there. In was it in Wollonga? There's a whole development that's done with round earth as well. So there is a bit of it about. Also, there are pressed soil blocks. So that's where you make round earth units, like just in a little formwork, and you've got these big arms, and you make pressed soil blocks, and of course also straw bale and render. It's not like essentially it is masonry. It's separate units, but they're not bonded together with mortar. Have either of you seen a straw bale building before? You have? Yeah. Where was the straw bale building?
In my country.
All right. So what?
That is quite traditional way.
Right. Okay. Yeah. And what is your country? Where are you from?
Korea.
Korea. Right. Yeah. And so
very countryside.
Yeah. Okay.
Yeah, I can see very countryside. So building, some of the house.
Yeah.
Strawberry. Yeah.
All right. Yeah. Cool. And that's like a rice straw, is it? So, or what sort of straw do they use?
Oh, rice. Yeah.
Rice. Yeah. Yeah. So yeah. Yeah. Oh, cool. Yeah.
People 1970 Korea normally people growing rice then
Yeah. Yeah.
selling that and make money.
Yeah.
But after that, what's that? Industrial revolution.
Yeah. Yeah.
After that, all the people left. All the people left from
Countryside.
Countryside and going to city.
Yeah.
You know what I'm talking about.
Yeah. Making lots of cars and yeah. Yeah. Yeah.
That's all strawberry.
Yeah. Oh, great. Yeah. I've never been to Korea, so yeah. Yeah. So I didn't know about that. But I've seen a lot of mud brick around the world in places, but yeah, not a lot of straw bale. But here in South Australia, there's a place up near Gawler called the Food Forest, and that's it's a biodynamic farm. So it's all organic farm. They do a lot of stuff, but they also do a lot of straw bale building workshops there as well at the Food Forest. So concrete blocks. Yeah, I think concrete blocks are great. Good way, or very quick way of doing solid masonry walls, and very versatile. And then down on the bottom right hand side here, these are Hebel blocks. So that's your aerated autoclave concrete. With with your concrete blocks, you can also include vertical reinforcing for core filling. So you run the reinforcing down inside these channels and fill those channels up with concrete to provide concrete structures throughout your wall. But you can also have longitudinal reinforcing as well with some concrete blocks. So they've got accommodation at the base here for running your longitudinal reinforcing the walls. Some very interesting stacked stone approach. So that's an interesting approach to stacked stone. So that's sawn granite. Yeah, it'd certainly not be cheap. I don't think to produce that. So with your brickwork, you've got various different types of bonds. We won't labour on this too much because unless you're a bit of a brick aficionado, you're not going to be called upon to know this stuff too much. But this stretcher bond, that's typically what you see with a brick veneer, because brick veneer, you've got a single layer of brickwork. But other things like English bond and Flemish bond, that's where you've got two leaves of brickwork working together. So we'll have, and by the way, bricks apart like that, like this, is called cavity brickwork. Bricks together is called double brick. And that's where you use these types of bonds. So your double brickwork happens like that. So I've got two stretches here and a header. So if I turn that around like that, I end up having two stretches and a header. And so if I was to do an English bond, well that's pretty much the way I do an English bond. So two stretches and then a row of headers on top of that, etc. The reason for that is because by sharing bricks between your leaves of brickwork, you end up producing a very thick masonry wall. They give each other strength. If you did a double brick wall, but then didn't do any, or didn't alternate between stretches and headers, then those two leaves of brickwork aren't really tied together and they can fall apart. But what we do, actually, I'll just keep going through the slides. So various other different types of bonds as well. So between your bricks, you have to use mortar. Mortar should be seen more as a material to provide compressive strength to hold the bricks apart rather than glue the bricks together. So mortar is not designed so much as a glue, but as a bedding material to provide a secure bedding for the brickwork and to hold the bricks apart. Mortar mixers have to comply with an Australian standard, so that's Australian standard 3700. That's the Australian standard for masonry construction. And a general, like how to say it, a rule of thumb mix is 1 cement, 1 lime, and 6 sand. But yeah, far be it from me to tell a bricklayer how to mix their mortar. I think that's certainly part of the art and what you learn as an apprentice, mixing lots and lots of mortar. So the mixing process is called batching. By the Australian standards, it's supposed to be carried out by volume, but much like baking a cake, you've got your bricklayers that I guess make more of an art of it rather than a science of it. Bed joints and perpends should be 10mm width. Where you differ from that, and actually, this comes into brickwork dimensioning. So I said it's really important to know the standard size of a brick, the 230, 110, 76. One of the reasons for that is not only so you can judge the height and so on a wall, so you can look at a wall and go, oh yeah, that's 4.3 meters long because I've counted this many bricks, etc. That's good, but as designers, what you don't want your bricklayers doing is just cutting lots of bricks. You want to ensure that where you put in your door and your window, if you've got a space between your door and your window, that is in units of 240 millimeters minus 10 millimeters. So your brickwork dimensions. and I'll pull up a brickwork dimensioning chart later on as well. So buildings should always be designed, if you're using brickwork, based around brickwork dimensions. If you don't, then your bricklayers just have to be cutting lots of bricks, and you get bricks that are in thirds and quarters and so on, and it just doesn't look very good either. Bricklayers only like to cut bricks in half, and that's it. And so when you get to a door opening, you'll have full bricks and then half bricks, because you've got that stretchy bond of them overlapping. But that's it. That's all that bricklayers will want to do. If for some reason your windows and doors don't work in with those brickwork dimensions very well, but are fairly close, what a bricklayer can do is stretch out their perpends. So it says here they have to be 10 millimeters in width, but they can actually stretch them out to 12 millimeters or so. So make them slightly wider and gain 2 millimeters each brick. But yeah, you won't be a very popular draftsman with a bricklayer if you're getting them to do that. Joints are formed as work progresses. So as the mortar goes off and stiffens, it can be raked out nicely. So you can't do the raking too early. When the mortar is still soft, it doesn't form well, and then you can't do it too late either. It's about that Goldilocks period of the mortar being sort of gone off, but it's still a bit pliable. So cleaning up your joints, that's referred to as tooling, and we've got a few tools in here for doing tool joints or raked joints. That's your standard one. So an 8mm rod for putting a curve in a 10mm joint. And then this is another raking tool for doing square cut or raked joints.
And just run it through the mortar.
Yeah. So you run it through the mortar and just scrape a little bit out. So as you're building your brick wall, you got your brick, and you put mortar on here like that. You trowel on there, and then trowel some on the end. Put it on and squish it up a little bit and nestle it in, and then you bring your trowel along and scrape off that little bit of mortar that's on the outside. So you end up having pretty much just like a flushed joint like that. But then when that mortar has gone off and stiffened enough to be raked out nice and neatly, typically this is what you do. You do a raked joint. So with this square tool, you go along and you rake that first sort of 10 millimeters or so of mortar out. But there are various other, that one's, sorry, I've got the pointy end. So that's for doing a V joint, the pointy end. This one doesn't have a square end to it. But your concave, that's done with this tool. So you run that along to do a concave joint in there. But this raked one, that's your typical joint that you'll see. And have a look at some brickwork, of houses you visit, and have a look at that. Sometimes you'll see these deep raked. That was a sort of late 70s, early 80s sort of architectural feature with sort of high-end buildings. Sometimes within cavity brick buildings, you've got single leaf masonry walls as well. You are restricted to the height you can go with a single leaf masonry wall. There are ratios for your width of masonry to your height, and that I think is defined in AS 3700. Not entirely sure exactly where it's defined. I haven't looked it up in a long time. But you do have to be aware that with a single leaf masonry wall, you can't just go as high as you wish. But they also have to be tied back in to your external masonry walls with these brick ties as well. So every 300 millimeters, you have to have a brick tie. Brick veneer walls, typically what we deal with in South Australia. So that's where you've got a structural timber frame with insulation between it, and then a brick veneer on the outside. This one here, that shows some air cell cladding on the outside. Air cell is like a sisolation, except it's got little pockets of air in it as well, so it provides an R value to it. But typically you're going to have sisolation on the outside of your studs, and then you're going to have insulation in between your studs here, and then somewhere between a 25 and 60 millimeter gap before your brickwork. Stud work is fixed to masonry by wired ties at, it says 6 centres at 600 centres. So those wire ties that I showed you before. So on every stud, you've got a wire tie going on every stud, like that as you move along, and then those wire ties have to be at 600 heights as well. Except around doors and windows where they're every 300 centres. So that shows another type of wall ties. Yeah, what else do I have in here? Got a few other types of ties as well. So these some anodized ties, so anodized aluminium, and then
Just on the same thing before you show.
what's that?
This one.
Oh, it's pretty much the same. Yeah. So the same. Yeah, and that's a fairly modern type of wall tie. That one as well, and. Yeah. So that's a front face fixing one. And there we go. That's another type of wall tie which is actually quite common as well. That one that screws into the side of the stud. As I mentioned before, for any suspended floors, you need subfloor ventilation, and you do that via vent bricks. And cavity masonry. So cavity widths between 35 and 65 millimeters. Cavity masonry can be reinforced or unreinforced. Typically it's going to be unreinforced if it's brickwork. Also your cavity ties, much like your brick veneer ties, have to be at 600 centres. So those, and I'm not sure if I've got any, I'll have a look here quickly, see if I've got cavity ties. That tie is to go from external to internal wall. Once again, same. It doesn't appear that I've got any cavity brick ties in here. These are all brick veneer ties I've got here. Except for those couple there, I'll show you those in a minute. Like brick veneer, you have to have weep holes for drainage. So that's these weep holes down here. Does anybody know what blueboard cladding is? Have you seen blueboard cladding before? It's called blueboard because it's blue, but it doesn't stay blue for long. It's a thick fibre cement sheet that's put onto stud walls, and then it gets rendered over the top. That was a bit of a fashion, sort of around 2001 to 2004, to use blueboard and then render over the blueboard for that neo-Tuscan look, so that square house rendered facade, etc. But it was a much cheaper way of building a house than by building with brickwork and then rendering over the brickwork. But one of the telltale things to spot a blueboard rendered house as opposed to a brick rendered house was the brick rendered house still had all its weep holes down the bottom there. But yeah, that blueboard with render hasn't really shown itself to be a very good form of construction because you get movement in houses and cracking through the render of the joints of the blue board. So brickwork still has to resist lateral loads. So we still have wind forces acting on masonry, and I had to detail up the repairs to it was a very interesting job. A large Besser block wall in Norwood fell from one factory onto adjoining buildings. The reason so we had big portal frame building. So I'll just scrub away some of these things. So portal frame with I-beams like this, and then fixed down to concrete there. So, cool. Sorry, I've drawn my flanges there, really wobbly. Anyhow, so that's large I-beam. So we've got some sort of knuckle joint in here, like that, and then our slab, and then Besser block wall here, like this. Now, I said before there are width and height relationships to masonry when you've got a single leaf wall, so single leaf masonry. You can only go so high with a single leaf masonry, but still it needs to be tied back into something. Now, this property had masonry ties back to the portal frame, but they were these type of masonry ties. They just chopped off that end bit, and then they spot welded them or arc welded them to the I-beams. What happens when you try to arc weld something that's this thin onto something which is this thick with steel? Well, you have a very difficult time of doing that anyhow to get that joint. So many of them weren't joined very well. But you've burnt all this galvanizing, and it rusts right at this point. And so all of the ties had just rusted or not joined on properly to those I-beams, making the portal frames, and it just took a little bit of wind on the side of it, and just the whole thing came down, fell outside, and fell on some adjoining buildings, which wasn't a very happy scenario for the neighbours.
So after they welded, and then they didn't clean up and they didn't spray any gas.
Yeah, so they could have sprayed cold galv on there or something like that.
Painting.
Yes, yeah.
But they didn't do that. That's why that happened.
They didn't know. Yeah, and I think that's a really good point actually. But yeah, because you work with heavy gauge steel. Yeah. But you'd also appreciate how difficult it is to weld something that thin onto something that thick as well.
Nothing to me.
So you don't do the welding, but yeah.
No, I mean, yeah.
Oh, you can do that. You can do it, right?
Yeah. Nothing to me.
Yeah, right. Yep. Well, they should have had you for doing the job. But yeah, they'd all. When I saw it, there were just little corroded stumps of stuff there, and all the tires were all broken right at that junction there with the I-beam. Yeah. Probably because they didn't use corrosion protection. That's probably more to the point, isn't it? Yeah.
Oh, I don't know. Well, sometimes just what's that? Sometimes just TA do the work. I can do the work. That is very simple one. Probably do something. Just TA did it. Yeah, not boilermaker, not welder.
Oh, right. Yes.
Especially stick weld is hard to see one word. What is that? That is, stick weld is not.
Arc welding. Yeah.
Is,
Oh, very very hard to see what you're doing. Yeah. Or no?
the slag.
Oh, slag. Yes. Yeah.
Need to see metal tool and slug as well, but it is hard to see.
Yes.
And,
yeah.
They just did it, and then looks like it have done, but it's not.
Yes.
Just tiny word did it.
Yeah. Yeah.
I can see so many happening like that.
Yeah. Yeah.
At the site, so.
Yeah. Yeah. And it's got the slag on the top. They haven't chipped it away, and so they haven't
That's
revealed.
fine,
Yeah.
And
Yeah,
they
what they've
believe
done.
this is a strong word.
Yeah, but it's not. So to do a weld like that, on the I-beam you get a bit of a pull happening, and then you get your metal into that pull you've got working on the on the I-beam. Yeah. And melt that in together. Yeah. Cool. So brickwork still needs some form of lateral restraint against wind and so on. It doesn't have much resistance to falling over. Also, when you build a cavity brick wall, you don't have a timber frame to tie your roof down to, either. And the way that is done is when you've got your cavity between your two leaves of brickwork like this. So we've got these leaves of brickwork, and we've got a cavity in between. What you do is in your mortar gap, and I don't have a 10mm rod, but let's call this one a 10mm steel rod. We put a 10mm rod in there, and that 10mm rod doesn't quite reach the outside of our mortar because we don't want that to be exposed to air, and we also don't want that appearance of that rusty rod rusting on the outside of our masonry. So that rod sits in there like that, and then you send a strap of iron down, like a looped strap of 0.8 by 30mm by 0.8 galv iron strap, and you hook it around that rod, and then wrap that over the rafter to do your tie down in that fashion. Can you understand that detail from the description? Or should I draw it up a little bit? Okay, so let's pretend that this is no longer a portal frame, but that's also another leaf of masonry. So you embed your 10mm rod there. It says on there, 900 from top of wall, but we typically specify them at 1200 from top of wall. But that's our steel rod in there, and then you'll have a top plate fixed on here and fixed into there. But if we just fix our rafter, so our rafter that comes down here, if we just fix that to the top plate, at best, that top plate is fixed to our top brick, and with a lot of wind, it just take the top brick off. So we can't rely on this fixing here. So we use the galvanized iron strap attached to our rafter, loops down around that 10mm rod, and is nailed again onto the rafter, tying the rafter down into that brickwork. So in elevation, this is our brick wall, and our rafters coming here like this, and then our 10mm rod sitting down there. Then if the wind tries to rip this roof off, it takes a big cone of brickwork with it. Well, it has to take a big cone of brickwork. The intention is that, does that make sense? Or you?
Sorry, I couldn't understand properly.
Right. So this is our brickwork. We're looking at that in elevation like that. So that 10mm rod is embedded into our wall down there, and we use a piece of strap iron to loop around our rafter. So with that rod embedded there and our strap going over the rafter like that, if we pull up on that rafter with enough force, because that rod goes through the brickwork, it has to take this brick which is above it. That brick will take those two bricks above that. Those two bricks will take the three bricks above that. Those three bricks will take, and you'll end up taking this cone-shaped piece of wall with you as you lift it up. So that's why the further you embed this rod, so that's 900, we embed it down to 1200, you end up taking that much brickwork with you if you try to pull it up. And it's actually surprisingly easy to loop it around that rod there as well, because you get your galv iron strap, in a long piece, and you put a bend in it, and then to feed it down, get it, and then pull it back up, so it just hooks around that rod. So it's easy to do that retrospectively, and that's also something that's fairly simple to retrofit as well, because for buildings that haven't been tied down properly, you just drill a hole through the brickwork, slot your rod in there, feed your strap from the top, and then mortar over that little drill hole. So it's not too difficult to do in a retrofitting sense. So there's a suitable tie-down strap detail. Trying to see what they've detailed in that. Okay, in that, yeah. So that's a different tie-down detail than I've ever worked with before. That's where they've got a galv iron strap going down the internal face of the brickwork. I'm not sure how that one's fixed in. Maybe it bends in. But that's not as simple as the 10mm rod. So wall ties provide strength and must be protected from corrosion, as per the Australian Standard for Masonry. So it connects the two leaves of masonry, or the masonry and the timber, to metal stud. So they stabilise those two masonry leaves and stiffen the wall cavity. They have to be embedded 50mm into the mortar joint, but they have to have 15mm of cover to any surface. That's once again so we don't get ugly rusting brick ties on the outside of our brick wall staining the brickwork. Should be installed to prevent moisture breaching the cavity. So the way that that's done is once again with that drip groove. So sometimes on your brick wall, well, in fact, quite often you'll get some moisture that runs down this internal, this outside, or the internal face of the outside leaf of brickwork. The moisture runs down there. What you don't want are your brick ties sloping back towards, well, like this way, sloping back toward your stud, because then if you've got water running down that face of brickwork, it then flows along the brick tie and gets into your timber. That's what you don't want. If anything, you want it sloping that way, but horizontal is fine because it has a drip groove in there to stop that happening. So this is a diagram showing the spacing of wall ties, and as a building designer, it's actually an important thing to check on site, to look at, to see that has been done properly, because as you could probably realise, it is a fair bit of work to go installing brick ties as well, and some brickies might take shortcuts on that. So your brick ties, these ones are at 600 centres, so 600mm vertically and 600mm horizontally, so that corresponds with each stud. Then at your windows, they have to be at 300 centres max. Typically they're going to be less than 300 centres max because you've got your stud work, your jam studs right near your window. So you have your jam studs in here, and then your windows fixed in to those jam studs. With cavity masonry, it's also possible to include insulation to meet the insulation requirements. You don't have much space in there, so you can't use batt insulation. So insulation batts are typically the cheapest way to achieve your R value. But because you can't fit batts in there, you use something like a PIR foam, which gives a high insulative value for a very thin thickness of material. Within brickwork, like brick doesn't respond very well to movement. So the way that's countered is with control joints. So these vertical joints in brickwork are control joints. Has everybody seen control joints before? No? So have a look at your house. Is your house a brick house? Is it? So go around, have a look at the walls on your house. You will have control joints in there. I guess the best control joints are ones that are not glaringly obvious. And so control joints like that, you don't really see that one very well. We see that because we've because we've got a picture of it. But you know, control joint like that, I guess that's not a very good one. That's, you know, that's glaringly obvious. You're not going to miss that one. So you have to have control joints for several reasons. One of them is because there's a little bit of expansion and contraction of brickwork and shrinkage as moisture is taken up and given out. But more so, it's for allowing any movement. So slabs, when they're under pressure, they do deflect a little bit. Concrete slabs do deflect a bit, and you need. What we want to do is we want to stop that happening. So when you do get some deflection in a concrete slab, these gaps open up slightly. So within your 10mm mortar joints, also your brick control joint, you use a piece of compressible foam like that. It gets compressed slightly, so that when it opens up slightly, that foam takes up that opening, and then when it closes up, that foam can be compressed a bit. So it keeps that brick control joint fairly well sealed. And then on the outside of that, you use a mastic bead. Or another way of doing it without that. So this foam, that's pretty much how it's all done now. This one here, that shows this backing rod stuff. So that's where you just put the backing rod in, and then you do a mastic foam. Oh, sorry, a mastic seal on the outside of that. So you have to have control joints whenever you've got a change in wall height. So for this building here, we've got this main portion of building and then a lean-to section. Even if those two portions were built at the same time, you need to have a control joint in here, because whenever you get stresses on a building, that they will express themselves at junctions like this, where you've got you know, here you've got a thing which is this thick, taking that bending force or that bending moment, and then there you've got a thing that's only that thick. It's going to be at that point there that you get opening up. You also have to have articulation joints at any openings that are larger than 900mm wide and by 900mm tall. So for an 820 door, that's a 900 opening. So 820, that's your standard size door. So you need to have a control joint all the way up the side. But of course, you're going to that's going to be a very simple thing. So certainly here, our door height's going to be 2100, and so we have a short section of control joint. But with your window that's 900 wide, you have to have a control joint down the side of that as well. So placed in positions which doesn't compromise the strength of the structure. However, typically in brick veneer, your brick isn't taking a structural role. So AS 3700 requirements are, and I'll go through it fairly quickly. Opening movement of joint shouldn't exceed 10mm. Closing movement shouldn't exceed 15mm. Width of joint to be not less than 5mm. Filler mastic not to impede the movement of the joint, and not to be toothed into a masonry wall. So that's where you have something that breaches that joint. So sharing bricks across that control joint. So it has to be a continuous control joint from floor to ceiling. That's all kind of superfluous anyhow. When bricklayers do brick control joints, they do them at 10mm. And bricks, when you buy them, hopefully they're being made by a reputable manufacturer who knows how much expansion and contraction is going to be happening in their brickwork. They've limited that because of their choice of clay, and you're not going to get opening and closing anything near that. Because your brickwork still needs to be tied together across control joints, so at every fourth course for cavity walls, you need to have brick ties which allow that opening and closing to happen. So that's what that is. So that goes into your mortar between your and that goes across your brick control joint. Also, brick control joints have to be for class M soils. Well, actually, yeah, maybe I shouldn't say it off the top of my head, but I think it's for class M soils it's around 5 meters, and for reactive soils or for highly reactive soils it's at for highly reactive it's at every 5 meters. For class M soils it's at 6 meters, I think. So you have different spacings required for control joints dependent on the reactivity of your soil. But typically with that, either those control joints being every 5 meters or every 6 meters. When you've got something like a garage here, because you don't have any windows in there, you have to choose a place for a control joint. Typically, the place chosen for that control joint is right in the middle of that wall. So right in the centre, you nominate a brick control joint there. But then around the rest of your building, where you do have doors and windows happening, you end up having control joints along the side of those windows. These ones here are called ARJs. Typically, you don't specify an ARJ. So an ARJ is an articulation joint. Within the National Construction Code, it says you need to have articulation joints, you need to have expansion and contraction joints, and you need to have brick control joints. Now, a brick control joint is actually both an articulation joint and an expansion and contraction joint. So simply what building designers do is they look at the limitations around a brick control joint, and they specify everything as a BCJ around the building. So that's what you do. So a brick control joint, the limitations on that are the sum of the requirements for an articulation joint and an expansion and contraction joint. Does that make enough? Yeah. But yeah, basically the short of it is we specify brick control joints. I'll flick through that. So that's that's for most of what we've covered already. Some details here. Oh, that's another form. So we've got that form of tie as well across your brick control joints. With your cavity block work, you also have horizontal reinforcement to help control shrinkage of the walls. I mentioned before the place at Murray Bridge that had concrete bricks, so small bricks made of concrete that weren't fully cured, and when that house was built and with the mortar, everything just sort of shrunk and opened up those control joints. This mesh helps to control that shrinkage as well, and spread that shrinkage evenly through the wall. But it also provides a tensile strength in terms of any movement of that wall and that twisting and opening up as well. So it consists of two steel wires of 3 millimeters diameter, sort of welded into a ladder fashion, either of these sort of profiles, and then that's laid on top of your block work to go into your mortar. A very important aspect for building anything, but particularly with masonry, is moisture prevention. So you have to prevent moisture from making its way up through the brickwork. Now, an old way of doing that was that one. That's pressed clay. It looks sort of like a clinker brick. So yeah, the old way of doing that was with what are called clinker bricks, which are double fired. So it gets fired once in the kiln and then goes back in and gets fired again. They end up being incredibly hard, but slightly more brittle bricks. But they're very hard bricks, and they're good at stopping moisture coming through. You probably would have seen a lot of old cream brick houses around with a band of dark brown bricks at the bottom. Has anybody ever seen that before? Yeah, have a look for it. If you, what is it? Fulham and so on in that area, as you go down Henny Beach Road, driving towards the beach or so, in the back blocks around there, it's quite a few of those cream brick houses with a layer of dark bricks right at the bottom. They're called clinker bricks. That's to stop moisture. That's the old way of doing it. Before then, there was, and in conjunction with that, there's also layers of bitumen. People use bitumen as a layer in the bed joint to stop the movement of moisture. But now what we use is this embossed black polythene film. Has everybody seen that stuff before? Yep. So yeah. Oh, there we go. Got some just right there. That stuff. So yeah, have a look at it. So it's embossed, so it beds in well with the mortar. So that just goes in under your bottom layer of brick to stop any moisture coming up. It's also typically laid in your bottom layer of brick, and then you have a weep hole above it, and then you carry it up and nail it to your timber stud, so that any water that comes down inside of that brickwork hits that flashing at the bottom and goes out the weep holes. But it is essential that is put into the brickwork to stop the moisture coming up. I once saw a house, a new built house, which was complete. I was doing the final inspection of that, and I saw that they hadn't used, they'd used that on only part of the wall. They hadn't carried it all the way around, and I had to make mention of that. I don't know how they rectified it, whether they had to cut in under the brickwork and install. I don't know, but it'd be a horrible thing to have to rectify. But yeah, I've only ever seen that once. But yeah, still an important thing to check. So that's your standard your standard moisture prevention. However, it's also commonly used as a form of flashing as well. So exactly this same material gets used on your timber stud around your windows and things like that to direct moisture. So flashing is any impervious piece of material that directs moisture to where you want that moisture, as opposed to where you don't want it to be. So damp is a fairly destructive force, well, not force, but destructive element in buildings. So it attacks particularly older clay bricks. So this is an older clay brick which hasn't been fired as much as the other ones. And also note that that's not a standard size as well. That's another thing you'll see about. That's another way to identify a very old building, is that you don't get it so much in Australia because we moved to the standard brick very quickly. But in places like the Netherlands, where you walk around the streets and you've got buildings that were built in the 1600s and whatever, the older the building, the smaller the brickwork. Because as technology developed, as firing technology developed, they are able to make larger and larger bricks. Australia, we pretty much moved to these ones almost straight away, but still there are some very old buildings in Adelaide, around Port Adelaide and things like that, that do have these small bricks like that. So that's history. No, it goes this way the same. It's laid like this. You see the height of that, so it's much thinner, because they didn't have the firing technology to be able to make something that was this thick at that point in time. So yeah, so it's slightly thinner brick. But yeah, these old bricks, they're not as thoroughly fired as the new bricks, and they're also far more susceptible to moisture and deposited salts. The moisture gets into the brick and then comes out as salt, comes out and deposits salt on the outside. Those salts form crystals. They wedge off to tiny little bits of brick and very slowly eat away at the brick or the masonry wall. Big cause of that, so we've got breakdown of damp-proof course. but the massive, or the overriding cause of it is defective plumbing. And also with our reactive soils in South Australia, when you get a pipe which is defective and it's leaking, it soaks that soil swells, puts more pressure on the pipe, and you get even exacerbated damage to those pipes and moisture damage. I think so. Moisture damage would probably be the main thing for building damage that we would see. Also, condensation is also that's not to do with the masonry construction, so to speak, but it's more in line with the as a result of the insulation of the building. Where you've got very cold air outside and warm air inside, particularly if you have a gas heater, which is putting burning hydrocarbons and putting water vapor into your air. That warm, moist air, when it comes in contact with anything cold, it loses its moisture, and then that moisture is deposited as condensation on your walls or your ceiling also. And from that condensation, in severe cases, you can get mold happening. And mold is bad for buildings, but it's also really bad for people. So there's plenty of health side effects to living in a moldy house. Also, other things that cause damp in buildings. So a bridged cavity in walls. So if we've got those tyres running the wrong way, or pieces of mortar there. Also blocked weep holes. So if weep holes get blocked, moisture can build up and go to where it's not wanted. So damp moisture can penetrate through external wall to the cavity and down inside face of the wall if the brick tiles are facing the wrong way. Cavity must be clean and have an uninterrupted damp-proof course, and flashings over doors and windows. So all of you flashings over your doors and windows, do you guys know what I mean by flashing over doors and windows? Should I bring up a picture of that? What's that?
Not too sure.
Not too sure. I'll bring up some pictures of that in a brick veneer with a structural frame, hopefully. Oh, that's a good one. We don't have a top flashing on that one, but we've got side flashings happening on that one. So what we've got is we've got that embossed polythene film. That's going to the back side of your windows, and it's nailed to your stud work to ensure that any water that gets in those side bits, that's directed down. So it's not going to go inside the house. I'll see if we've got a better one. Better image for that. So once again, some side flashing and flashing underneath. Okay, no, we don't have any really good images. I might just search for timber frame and then see if we've got one with windows installed already. No, so these are like lots of oldie worldy portal frames. Yeah. No, unfortunately, I can't. I'm not having much luck in regards to finding, to seeing some good images to show that flashing carried around windows. We had that one with the side flashing, but typically what you also have is you have a flashing across the top here that's carried 150 millimeters past the edges of the window to ensure that any moisture that gets in there gets directed down the inside face of the brickwork. So ways of doing that. So you have to, to ensure that your cavity doesn't get breached, you have to remove the excess bits of mortar, and that can be done also by packing the cavity with old cement bags and things like that. Or you can leave bricks out, and then you clear out the mortar, and then you prepare a brick with mortar, and you slide it in and trim up that mortar at the base when you finish the wall. Flashings can be made of copper, bitumen coated metal, zinc coated steel, polythene. A lot of old houses use lead for flashing. You don't use lead anymore for flashing because of health concerns. There are also aluminium flashings with a sticky bituminous backing to them as well, and also other. There's also another type of flashing material which is almost like a double-sided tape, which is called one-on-one, that you can stick something on and then stick something onto that one-on-one material as well to produce a flashing. Flashings at the base of the wall can be used to replace the damp-proof course, so that's what I talked about earlier, where you have your damp-proof course at the base, and then you carry that up high, and then you fix that onto your stud wall. Over openings, it must extend 100 millimeters past the side of the opening and extend across the cavity, so across to the stud work, and must turn up 150 millimeters and be fixed to the timber frame. Also, when you've got a parapet wall scenario, flashings are incredibly important. These are two flashing details. I much prefer the second option, option B. Can anybody think of why option B is a better option than option A?
Flashing goes to the outside.
Yeah. So in flashing B, all our moisture goes onto our roof there. So with option A, what you get is when this gets breached, if you've got weep holes on the street front of your parapet wall, you get these little black marks for where moisture has come out of weep holes. Looks fairly, can look ugly if it gets breached. So you want to have a flashing detail like that with a cavity masonry wall if you're doing a parapet wall. Do both of you know what a parapet wall is? Have you seen parapet walls used previously, and what you use a parapet wall for? So parapet walls are basically a wall that extends past a roof. So it's for whatever scenario where you want to go hiding your roof. So that might be because you want to get a very rectilineal shaped building. You want to build do you know the architect Sean Godsoe? Also, so he builds boxes basically. So parapet walls to make it look like a box rather than a thing with a roof on it. But used a lot for shop fronts and things like that. I'll just quickly, once again do a search for parapet walls there, see what we come up with. So that's a parapet wall. That's where you've got your wall going up past your roof line. But plenty of parapet walls in modern residential construction as well. So these are so in this scenario here, you've got a low pitched roof in behind that. But to give it a clean aesthetic, you carry your brickwork up past the roof. That simply means though that you can't have an eaves gutter because you don't have eaves. So all of your water gets contained behind that parapet wall, so it's very important how that water is dealt with. And so that's, you know, that's essentially dealt with with a parapet gutter, which is another form of box gutter. But yeah, there's plenty of scenarios where that happens in fairly standard residential construction as well. With cavity masonry and also brick veneer, you need to support your bricks over an opening. So if you've got a window, so a very cheap way of building is to not have bricks above your window. So you can just, you know, have some sort of timber infill or fibre cement sheet or something above your window. That looks very cheap. Has anybody ever seen that before? It's not the standard, but that's the cheap way of doing it. The more expensive but more common because of the better aesthetic is whereby you have a steel lintel in place and you carry your brickwork over the top of your window. You can't just carry brickwork over the top of your window without having something supporting it underneath, because otherwise you get bricks just falling down. So those lintels, essentially you don't make them, you buy them, and you buy them from Prida or something a company like that, because they've done all the engineering on them. So you buy a lintel for this span, a lintel for that span, etc. So you don't have to engineer them yourself. And there are lintels for various different scenarios and situations. But by and large, that's the sort of thing you'll be dealing with for a standard brick veneer house. So that'll be your garage lintel. So that's carrying the brickwork all the way across your garage. So that one's quite deep. Whereas these are your much smaller openings. And that one's probably toilet window or something like that, 600 wide. You also got T lintels like this for use in garages as well. So you have a brick that sits on there and a brick that sits on there, and the T goes up inside your cavity. So all that you'll see is on the underside of your brickwork is a flat plate of steel on the underside of your brickwork. But you've got this T section which is going up inside your cavity, providing that flat plate of steel with strength. So here's a actually it's an excerpt from Australian AS 3700, may well be, speaking about the maximum clear span of various different lintels. So I think I may have, you'd probably know what EA stands for, wouldn't you? Given that you work with steel,
yeah.
if somebody says if somebody writes EA like 50 EA, what does that mean for steel?
Angle.
Yeah, equal angle. Yeah. So there we've got a 90 by 90 by 6 EA. That means it's an equal angle. An equal angle is where both sides of that steel angle are the same length. So 90 by 90 by 6. This will be 90. This will be 90, and it'll be 6 millimeters thick. Our steel lintel. 90/96. Although when it's an equal angle, you don't need to write that first thing. You just go 96 EA. Can you enlighten us on what a UA is?
Uneven angle.
Yeah, and so there we've got, it's 150 high, 90 wide, and then 8 millimeters thick. So these are the spanning capabilities of those lintels for these particular roofing scenarios where you've got loads transferred from your roof onto your wall. Oh, what is that? Oh, that's it. That's why it's not going any further. That's the end of the slides for masonry. So yeah. That's it for what